Transformations. It starts with compositions. Okay. Like, what did we do in unit 5? We started with like composing. And then we realized if you compose them and you undo itself, that we have this concept of an inverse. And that an inverse of a function will undo that function, get x. And then that helped us understand how if we have some sort of composition inside of a function, how the transformations end up being like an inverse. We will have to undo the things that are being done. So we actually understand that this A ends up being a horizontal dilation, but, and this is why we like think about solving this equation, A times x plus C is equal to, just some input value you want to find. If I wanted to solve for x, I'd have to divide by A and then subtract C. This is why this is a horizontal dilation by a factor of 1 over A because of that inverse concept. And this is why this is a horizontal translation to the left or opposite of what we think. I don't know why I did A and C. Usually we put A here, we put B here, we put C here, we put D here. The horizontal dilation is 1 over B. The outsides affect the function value, the f of x values. You would then take that output, multiply it by A, then add D. So you would vertically dilate. You take your y's and times A. Here you're taking your x's by 1 over B. Then you're taking your x's and subtracting C. Here, this would be a vertical translation. And it's very much understood if you were good with the sinusoidal graphing. It came from this understanding. So it's like you should be able to go back and forth. Now, this statement, horizontal translation -4, means you're going left 4, means you're taking your x values and subtracting 4. We need a plus 4 in our function. I mean, that's it. Okay? The domain is our x's. What do we do to our x's? We would take our x's and we would have to plug in values where you would subtract 3 and you would get -5. And you subtract 3 and you get 12. This is like the idea of understanding the inverse. What do? You take your x's and you add 3 to them. You like solve the equation. So adding 3, I get -2 and 15. Range, y's. Taking our function values, what do we do to them? Our function values are coming from f of whatever that x plus 5 is. Those are our y's. We are then going to multiply our y's by 3 and then subtract 2. So I'll take -3 multiplied by 3, subtract 2, -11. I'll take 2 and take 3 times 2, subtract 2, and I get 4. Calculator doesn't help you here. Range, y's, times -2 plus 8. $20. This is when y is -6. Here's when y is equal to 4. Okay, make sure you put it in order, smallest to greatest. More y's. Did we just do this? Yeah, we just sit. Cool. I can show you how this works, but you can just tell that your y values of g are going to be multiplied by 3 and then add 2, so you get 17. You're not going to change the x value, but watch. Y equals 3 times g of negative 4 plus 2. Y equals 3, so it's like y of negative 4. Y of negative 4 is 3 times 5 plus 2. Y of negative 4 is 17. Negative 4, 17. I mean, you probably don't do that. Okay. You can just understand what's going on here. The x divided by 2, to undo inside, you need to multiply by 2. Horizontal dilation affects our x's. You're going to have to multiply them by 2. Vertical translation, add 1. That's the point. What's another way to show that? What's up? Hold on, I'm still recording a video. Yeah, I have like 6 problems, guys. Ooh, maybe more.
Oh, did you pause? Put on pause.
I've not paused it yet.
Oh, no, so we can get in it?
No, don't get in it. I don't want to get fired. Don't get fired.
Oh, that was quick, Mr.
Cool. If I plugged in 12, it would turn into 6. G of 6 is negative 1. Add 1. Boom. Works. There's a vertical asymptote at x equals 3. There's a horizontal asymptote at y equals 2. This minus 7 is going to adjust my vertical asymptote. It's going to be a 10. Taking my y's, multiplying them by 4, then adding 1. Just want to make sure this works out. Let's say I have a asymptote at negative 2. Let's just create some function that has an asymptote at negative 2. Negative 2, x over x plus 2. If I took those y's and multiplied them by 4, yeah, that would turn into negative 8. And then if I added 1 and I plugged in infinity, I would get negative 8, still plus 1. Okay. All right, it works out. It's nothing crazy going on with the horizontal asymptotes. Times negative 2 plus 1. The horizontal asymptote is that a y equals horizontal line, but it's a y equals value. So vertically changing things will change the horizontal asymptote. Take your x's times 2, take your y's plus 3. Take your x's, divide by 2, take your y's, add 1. Take your x's plus 2, take your y's minus 1, shift to the right 2, down 1. Recommendations for these questions are to use points and just like make a table yourself. But you should be able to see it. 3, 1 is going to go to 5, 0. There's 5, 0. Take your x's, subtract 4, vertically flip. Would that work in an opposite order? I mean, order of operations says work inside parentheses, inside functions first, and then work outside. So I don't think this is correct that it has to be in this order. I think you could flip it. But it is a vertical reflection because of this negative on the outside. It's a vertical reflection, so it's reflecting over the x-axis. Don't mess up an x-axis for a y-axis. Flipping your y's reflects over the x-axis, and then we are going left 4, so the horizontal translation is negative 4. These are fun. H of 9 is G of F of 9. F of 9 is 5. G of 5 is 4. Love these questions. K of 3 equals F of G of 3. G of 3 is 5. F of 5 is 8. F of 1 is a half. G of a half is 9 to the 1 half minus 8 times a half. What's 9 to the 1 half? Well, you have your calculator. No, don't use it. 3. A half power is a square root. You should know that. 3 minus 4 is 9. Inverses. Woo! Flip-flop the points. If F's got the point -4, 3, F inverse has to take that 3 and map it back to -4 to undo what's being done. If F's got the point -2, -1, the inverse has got to undo that which is done. If F's got the point 2, -3, the inverse has got to have the point -3, 2 to undo what F did. So I'm looking for 3, -4. There you go. And the other points. Okay, what is the minimum value of K, where K is H's inverse? Well, here's H inverse, which is K. I mean, it helps to have points down to know what you're going to have. What is the minimum value? -3. Six. What we didn't talk about is like the concept of invertibility, how you can only have one output for an inverse. And this is where we kind of encountered this with arc sine, arc cosine, arc tangent, sine inverse, cosine inverse, tan inverse, how they only exist in two quadrants. They don't give you all of your possible angles that produce the ratio. They're talking about functions that are like increasing for a reason. You can't have two of the same outputs because if you invert that, it won't be a function. You'll have input that will output those two like values. If that makes sense. Like if this is the 0.13 and this is the 0.43, the inverse would have to have the 0.34 and the inverse would have to have the 0.31. But if you have that, then it's not a function. So keep that in mind, the whole concept of restricting things. Sine inverse, cos inverse, tan inverse has to be restricted. And that's what goes on here. Log base 3. Now, the log base 3 of x minus 4 means can't plug in 4 or anything less than 4. You would kind of be going this way. Now, can you construct this? Yes. Now, what's going on with the log base 3 of x minus 4? The x's, let's talk about the domain and range of G. The x's are bigger than 4. The range are all real numbers. Yeah. That means for the inverse, the domain is going to be anything, but the range are going to be the y's bigger than 4. Can we construct this inverse? Yeah, sure. Like if I have y equals log base 3 of x minus 4, if I asked you to do it, take 3 to the power both sides, add 4. Get 3 to the y plus 4 is equal to x, and that would be like the inverse function. So what would it be? The domain, my inputs could be anything, but my outputs have to be bigger than 4. That makes sense. So the inverse can be constructed. The graph of G inverse is the domain of all real numbers. The range is y equals 4. That's why that's wrong. Y greater than 4. All right, we'll blow through these. G of 4 is 7. F inverse of 7 is 2. F's got the 0.27. F inverse has the 0.72. F of 2 is 7. G inverse of 7 is 4. G's got the 0.47. G inverse has the 0.74. F inverse of 7, F's got the 0.27. F inverse has the 0.72. G inverse of 2 would be 7. G inverse of 2 is 7. F of 7 is 5. If you're unsure of any of these problems I did, you just got to understand that concept that if F's got the 0.27, F inverse has the 0.72. If G's got the 0.24, G inverse has the 0.42. And that will help you. If you want to create more tables for yourself, you can go ahead. F inverse of 3. F's got some point that's y coordinate of 3. I'm trying to find that x coordinate of F that produces a y coordinate of 3. That point is -4. This is when we did the problems with like the fractions and try to get you to think about applying a slope. And you guys all freaked out. Remember this? Gosh, good times, huh? Like, what did you just do with the slope? How did you get this point? I can't find this point. It's like, oh, gosh. That was frustrating as a teacher. We have those moments that are frustrating. So I'm just prefacing this. Unit 6 we're skipping. Why? A lot of the solving and the trig stuff occurs on the free response. I talked to the other teachers and they're like, oh yeah, that's what's going to happen. So I don't really know the answer to this, just like off the top of my head. If you do, great. H is increasing concave up. You can think of an exponential function. The inverse of the exponential function is going to be increasing concave down. So increasing's invertibility becomes increasing. Concave up's invertibility becomes concave down. That's the best I can do. Think of like an actual example. Exponential function, it's inverse logarithmic. If you're not sure, plot some points that show those characteristics, flip them, plot those points, see what's going on. All right, that was fun. Lots of good questions from Unit 5. Transformations, invertibility, that stuff. Peace.